All right, today we're going to specifically focus on proving the Pythagorean theorem identity because we didn't do that last time. And identify the sine, cosine, and tangent of any point on the unit circle that is used to identify the quadrant. All right, so the unit circle we talked about last time always has a radius of 1, hence unit. Because it has a radius of 1, we can relate it to all other circles because they are all similar. So this is where that idea comes in about the thing. So remember last time we talked about this pattern. So the pattern last time we had 1, 0 because the radius is always 1, and 0, 1 as our bookends for x and for y. Then as we go around, this, remember 1 is the equivalent of square root 4 over 2. So then we go square root 3 over 2, square root 2 over 2, and square root 1, which is just 1, over 2. Those are all our x values going up. This is coming from our 30, 60, 90 triangles and 45, 45, 90 triangles. Okay, and 0, this is just, think of it as 0 over 2. So this is square root 1 over 2, so this becomes 1/2. This is just square root 2 over 2. This is square root 3 over 2, and ending us on 1. All right, that's the pattern from last time. If you also remember, I talked to you about how if you take the cosine values, because they're adjacent, are always your x values. And your sine values are always your y values because they're the opposite values. Okay, so sine is x values, cosine is y values. Cosine is x values, sine is y values. And from here, we can prove that thing that I talked about before. So if this is the unit circle, our hypotenuse is always 1. So this is 1, this is 1, this is 1. I mean, our radius is always 1. All of those are a length of 1. So if we take our cosine squared, it doesn't matter which cosine, because they're all the unit circle. And we add it to our sine squared. Now remember, this is x squared plus y squared. So if we take our x value and square it, plus our y value and square it, it should give us 1 squared. Because that's our hypotenuse of our triangle. Well, 1 squared is really just 1. So cosine squared plus sine squared will always be 1. Isn't that cool? All right. So we talked about some patterns. Now we're going to continue those patterns. So we're going to talk about degrees versus radians here. So this is 0 degrees or 0 radians. This is going to be 30 degrees, 45 degrees, and 60 degrees, and 90 degrees. If we talk about radians, this goes from 0. This is going to be pi 6, because that's 30 degrees. It's a sixth of half the circle. And this will be pi fourths, because it's a fourth of the circle. This is pi thirds, because it's a third of the circle. And this is, well, a third of half the circle. And this is pi halves, not pi over pi. Pi halves. Okay? So then this one is at 1, 0. And this one up here is going to be at 0, 1. We know the one on the left should be at -1, 0. Right? So now we continue our pattern. So this is going to be square root 3 over 2. This will be 1 over 2. This will be square root 2 over 2. This will be square root 2 over 2. Then this will become 1 over 2. Square root 3 over 2. And then we're at 1. Now we're going to work the pattern, but we're going to go backwards. So we're going to go from 0. So that makes this 1 over 2. You'll notice they're at the same height. So they should end up at the same. Oh, and this should be -1 over 2. So if you notice, everything's positive. My cosine theta is positive. My sine of theta is positive. My tangent of theta is positive. So this means my x's, my y's, and my slope are all positive in this quadrant. It's all quite lovely. So let's look at the second quadrant. So positives are going to be my y values, which is my sines, sine of theta. And my slope is actually negative, so it seems that my x values should be negative here, which is my cosine thetas. And my slope is negative, so this is my tangent of theta. Okay? So then that's negative 1/2. This will be negative, negative, and negative 1. So that'll be negative 1/2. This will be negative square root 2 over 2 and negative square root 3 over 3. Then all these y values are at the same value, of the same height. So this one should just be square root 3 over 2. The next one's the same height as the one across from it, so it's square root 2 over 2. And then this last one's at the same height of the one across from it, so it's 1 over 2. Okay, now that I've figured out the top half of the circle, I want you guys to go ahead and do the bottom half. So I want you to figure out the sine of theta for each of these. Remember, this is your y values. The cosine of theta for each of these. This is your x values. And the tangent of theta, which is just your slope. What's the slope of the line coming from the center to that point? Okay. Once you finish that, we will meet back together here.